This is the video for lesson number 16, solving equations with a variable in the denominator. Please make sure you have the worksheet, lesson number 16, that goes along with this video, or remember that you can print a new copy from the eBoard. The lesson objective. At the end of this lesson, you will be able to identify when an expression is undefined and solve equations when there is a variable in the denominator. At the top of your page, there is a warm-up. So let's take a look. We have 5 divided by 0. Now you may be thinking that the answer is 0. However, picture this. You have 5 cookies and you want to split them up into 0 groups. I'd like you to take out your calculator and input 5 divided by 0 and see what you get. Notice you get this error message. So what I'm going to write down for now, and we'll come back to it, is error. Now try 20 divided by 0 in your calculator. We also get another error message. So hopefully you recall that you're not allowed to divide by 0. It just doesn't make sense. Our new vocabulary word to describe this is called undefined. So down below, an expression is undefined when the denominator is equal to 0. So the bottom part of the fraction. Or you can think of when you divide by 0. Let's take a look at the examples below. Example 1. What value or values for x will make this expression 5 divided by something undefined? Remember that undefined just means when the denominator equals 0. In this example, we only have the letter x, so we will simply say when x is 0, the expression is undefined. But remember, we don't like when expressions are undefined. So we want to say that x cannot be equal to 0, because if we input 0 here, we will get an error message. Example 2. What value or values for x will make this expression undefined? Notice there's something different in the denominator. What value can we plug in for x? Or if we plug it in for x, we will get 0 in the denominator. Some of you may already know it, but if you're not sure, what you can do is take the denominator and actually set it equal to 0 and solve. So this means when x is negative 5, the fraction will be undefined. Because if we plug in negative 5 here, we will get 0 in the denominator. We don't like that, so we will state the restriction that x is not allowed to be negative 5. Example 3. What value or values for x will make this expression undefined? So remember, we just focus on the denominator. We really don't even care what's in the numerator at all. So what number, when we plug it in for x, will make that expression equal to 0? You might just think of it mentally, but if not, you can set the denominator equal to 0 and see what you will get for x. And in this example, we get x equals 2. So if we plug in 2 for x, we will get 3 times 2 is 6, and 6 minus 6 is 0. We don't want the denominator to be 0, so we state it as a restriction. X cannot be 2. Okay, when you're ready, please turn the page. So remember, friends don't let friends divide by 0. We just don't like that because our expression will be undefined. Now what we are going to do is solve these equations that have a variable in the denominator. We will do 2 parts. Step 1. State the excluding value of x that would lead to a denominator of 0. So that's what we already did on the first 3 examples. We will write what x is not allowed to be. Step 2, Then we will solve the equation for x. When we're solving, our goal from now on is to clear the denominator. And we will do this by multiplying by the denominator on both sides. Let's take a look down below. Let's state our restriction. So what is x not allowed to be equal to? Look at your denominator. So let's write it up here. X cannot be 0. If it were, the denominator would be 0, and we don't want that to happen. Now let's solve. So step 1 is done. Our goal, remember, is to clear the denominator, this right here, by multiplying by the denominator on both sides. We've really done this before, and we used to do it with numbers in the denominator, but now we just have variables. Goes away. Remember, if we're going to multiply by x and divide by x, it really just equals 1, or it goes away. We must also multiply the right side. Let's rewrite our equation. We're left with 30 equals 5 times x. Well, that becomes 5x. And now you just have a simple equation that you need to solve. So in this case, x is equal to 6, which makes sense. If I plug in 6 for x, I would get 5. Let's put our answer in a solution set like we started to do the other day. Okay, so our solution is 6. That's what makes a true statement. And we always state our restriction, x cannot be 0. And that's it. Example 5. Let's state what x is not allowed to be. So take a look at your denominator. Do you know what x is not allowed to be? Try to think of it mentally. What would you replace x with that would give you 0 for that expression in the denominator? And I like to write it up here. If you guessed -3, you are correct. And now it's solving time. So let's multiply by the denominator. Multiply, in parentheses, always, goes away. We must also multiply on the right. Let's rewrite our equation. We're left with x equals. Now on the right, do you know what we're going to do to actually multiply 5 and x plus 3? If you guessed distributing, you got it. And go ahead and solve with the same steps we've been solving our equations with all along. And let's see what we get. A 1x minus 5x is -4x equals 15. To get x by itself, I will divide by -4. And we can't actually divide 15 divided by -4, and it can't be simplified, so I will just write my final answer. Okay, it's okay to put your negative sign with the 15, or you can put it with the -4. They're both equivalent. And your answer goes in a solution set. Since we got -15/4 for our solution, and our restriction was that x cannot be 3, we say our answer is okay, it works, and we move on. Example 6. Notice this time there are 2 denominators. So how many restrictions do you think there might be? Let's take a look at the left. What is x not allowed to be? Because it would give you 0 in the denominator. It cannot be 0. However, over here, there's something different. So we might have 2 restrictions sometimes. On the right-hand side, or in general, x is not allowed to be 2 also. So we just list them both. So sometimes there might be 2 restrictions. And we just keep that in mind. And now it's time to solve. I always like to start on the left of my equations, just like I was doing before. So I'm going to multiply by x on both sides. Now remember, this is equivalent to x over 1. So we are really going to do 3 times x. And the denominator just stays the same because we are multiplying by 1. Now I want to clear the denominator on the right. I'm going to multiply by the denominator, just like I did on the left. And let's rewrite our equation. Notice over here you need to distribute a 1, or you may already know that the expression will stay the same. However, we should all get 1x minus 2 equals 3x. And if you're thinking, do I really need that 1 there? You can get rid of it if you'd like. Let's continue solving. So I need to get my variables to one side, so I'm going to minus x. And we are left with negative 2 equals 2x. Last step, divide by 2. And we get x is equal to negative 1. And let's put it in a solution set. So this means if we were to plug in negative 1 for x up here, we would get a true statement. So if you want to try it out on your calculator, go ahead and see if it works. Keep in mind our restrictions was that x cannot be 0 and x cannot be 2. So since we got negative 1 as our answer, that works. We are done. Last one, example 7. All right, 2 denominators. We might have 2 restrictions. Let's take a look at the one on the left, x minus 2. So in this case, x cannot be equal to 2. If it were 2, we would get undefined. And over here, the denominator is the same, so x can also not be 2, but we don't need to list that twice. It's the same thing, so we just write it one time. Let's get to solving. I'm going to multiply, get rid of this denominator on the left side of my equal sign, and I do it in parentheses. Goes away, goes away. I must also do it on the right. However, notice this time that we are multiplying by x minus 2, but it also says divide by x minus 2 over here. The denominator is the same, so it also gets eliminated over here. All we're left with is x plus 3 equals 5, and we need to solve. You should get x equals 2, put it in a solution set, but always look back at your restriction. Now this looks interesting because I got 2 as my solution, but if I look back at my restriction, we've already stated earlier that x is not allowed to be 2. So I want you to think about if I got 2 as my solution, but x can't be 2, then what must the answer be? Now the reason we get 2, if we were to plug in 2 everywhere we saw x, we would get something for you to think about. 5 over 0 equals 5 over 0. Now this appears to be a true statement because both sides look equivalent. However, do we ever want 0 in our denominator? No. So what we're going to do for this one is we are going to reject our answer. Even though 2 is the solution, but it can't be 2, if we take that answer and reject it, we are left with nothing. So really, there is no solution for this one. So that's why we must always look back at our restrictions to see if our solution is acceptable. At the bottom of your page, it's your turn. You're going to try number 1 and number 2. You will state any excluding values right up here, just like we did with the other ones, and then solve. So I'm going to ask that you pause the video, do the work on your own, and then when you press play, the answers will pop up. So please pause. So here are the answers for number 1 and number 2, and I apologize, I'm not sure why I did not mean to write x cannot equal 0 over here for number 2. It should really be that x cannot be negative 1. For number 1, x cannot be positive 8. When we solve, number 1, you should get 17 over 2. We accept that because it's not equivalent to 8. it's okay. And on the right, number 2, we get -4/3 for our solution. And we accept that because it is not equivalent to -1, so it works, and we are done. Please come in with this worksheet completed tomorrow, any questions you may have, and please fill out your feedback form. Thank you.